Hey everyone, so now we're going to continue and we're going to talk about radians and degrees and converting between them, okay? So we have this figure below and it is a hexagon that is inscribed in a circle, okay? So we know the circumference is 2 pi r and the radius is the size of the circle and it determines the arc length. So remember that there's a relationship between arc length and circumference, and the radius is really important for that because it is part of your circumference. Radians is a little bit different. Radians is a measurement. It represents the number of times the radius goes around a circle. Okay, so the number of times the radius goes around a circle. A radian is defined by an arc of the circle. What we also need to know is that 2 pi radians is equal to 360 degrees. So in other words, 2 pi and 360 degrees are equal to each other. This one is in radians, and this one is in degrees. Okay, so that's going to be important for us to know. So therefore, in radians, the angle around the circle is circumference divided by radius, and then you can see that the radius r's cancel out, so radians is 2 pi. All the way around the circle is 2 pi. So what would the angle be in radians for half a revolution? So half of a rotation is 180 degrees, right? So if a full rotation is 360, half of a rotation is 180 degrees. And in radians, if a full rotation is 2 pi, half of a rotation is just pi. So that means 2 pi is equal to 360 and 1 pi is equal to 180 degrees. So these are going to be really important for me to know when I am making conversions, which you can kind of see here. So the conversions are, if I want to go from degrees to radians, I multiply by pi times 180. And if I want to go from radians to degrees, I'm going to multiply by 180 over pi. So it depends on which way I am going, what I'm going to multiply. Okay, so since these equal to each other, I'm going to kind of use it as my proportion in order to be able to solve. Okay, so let's go from here. I want to convert 180 degrees into radians, and then I want to convert 11 pi over 6 into degrees. So for A, I'm going to kind of work out A right over here. So I want to convert degrees into radians. Remember, degrees into radians, I'm going to multiply by pi over 180 is what this is. So I want to take a degree, and I want to convert to a radian. So I'm going to take 160 degrees, and I'm going to multiply by pi over 180 degrees. The reason why I do this is because my degrees are going to cancel out. I want the degrees to cancel out. So technically then I have 160 pi over 180. Now a couple of things cancel out here. Let's go. The zeros will cancel out. So then I'm left with 16 pi over 18. 16 and 18 have something nice in common. I can divide them by 2, and when I divide them by 2, I get 8 over 9, 8 pi over 9, which is the radian. And I finished, so I did part A. Let's take a look at part B. For part B, I am converting a radian to a degree. So the multiplication is not going to be the same. The multiplication, this is not writing. The multiplication is not going to be the same as here. It's going to be opposite. So I'm going to take 11 pi over 6, which is my radian, and I'm going to multiply by the opposite of what I have up here, which is 180 degrees over pi. Okay, so then technically I would have the pi's, since they're on opposite sides of each other, the pi's are going to cancel out. So let's just check this out for a sec, shall we? I'm going to get 180 times 11 times pi over 6 times pi, because when you multiply with fractions, you multiply across, so you don't crisscross because there's no equal sign in between. Okay, from here, you should notice a couple of things. The pi's are going to cancel out here, kind of like how the degrees canceled out right over here. So now we are left with 180 times 11 divided by 6. 180 and 6, they actually go into each other. 108, like 18 divided by 6, they divide out. So this actually turns into the following. Okay, and remember this is a degree. So this 30 times 11 is 330, which means that this turns into 330 degrees. So 11 pi over 6 is the same as 330 degrees. Super fun. Okay, so you have to know which way you're converting in order to know what you're multiplying. Okay, so here we go. Let's take a look at this one right over here. We have an arc length, right? What is the length of an arc that has a measure of 60 in a circle with a 10 centimeter radius? So arc length, remember that arc length? Arc length is something, it's a part of the entire circumference. So we need circumference. Circumference is 2 pi r. Okay, and we're going to use our proportions from last time, which said central angle over 360 degrees, because the angles go together, is arc length over circumference. Okay, we actually can find circumference because we know that the radius is 10 centimeters. So circumference is equal to, so r is equal to 10, right? Circumference is equal to 2 times pi times 10. So circumference is equal to 20 pi. We also know the central angle is 60, so we're going to start filling in some of these values. So I have 60 over 360, right? So I did this, I did that. Arc length, I'm looking for it. It says, what's the length of the arc? Circumference is 20 pi, right? So I have my proportion set up from here. And now I'm going to multiply. So because there's an equal sign in between, I crisscross multiply. I get 360x is equal to 60 times 20 pi, right? And so then that gives me 360x is equal to 60 times 20 is 1200 pi. Oops, this was supposed to be an x. I got so excited with the pi's. My bad. And then to get x by itself, I'm going to divide both sides by 360. And it looks like I get x is equal to 10 thirds pi. And the reason why we get that is some of these zeros cancel out. 36 goes into 120, and we can kind of reduce from there because they both divide by 12. This is in radians. Did you notice that? Because it's got pi's in it, it's in radians. So if I wanted to, I could convert this into degrees and so forth, but you don't have to because it is a length. And so it's possible that you can get lengths in terms of radians also. All right, so you're going to try a few conversion problems and let me know if you have any questions, but the key to the conversions is this right here. The pi over 180, 180 over pi, depending on the direction that you're going in.